again, what you see today will be the quiz tomorrow. Then we take a break for a couple of days, and I can't remember when the next one is, either next Monday or Friday. Can't remember, but we take a break. So what you see today, that's on the quiz tomorrow. Your entire mathematical life, when you've seen an angle, it's been measured in 50 degrees, right? Degrees. I'm going to show you a new way now to measure an angle. All right, it's actually another measurement other than degrees. Like your desk in front of you, if I said measure it, you could do it in inches, right? You could do it in feet. Well, an angle now, we can measure it in degrees, which you've done your whole life. Or what I'm going to show you today, you can measure it in what's called, anybody want to take a stab at that one? Radians, yes. So an angle can be measured in degrees, or it can be measured in radians. Okay, radians. So how do degrees and radians compare to each other? 1 radian is about 57.3 degrees. That's how you can kind of visualize it. 1 radian is about 57.3 degrees. Now that's rounded. Okay, that's rounded. Look on your, what do you need, Tim? You good? Okay. Look on your sheet. Everyone see where it says radians. Do you see how 1 radian equals 180 over pi? Why doesn't it say 57.3? Here's why. Watch me on my calculator. If I do 180 divided by pi, that's how many degrees actually are in 1 radian. But I just rounded it about 57.3. And you guys, instead of using 57.3, you're going to use 180 over pi. All right? So here we go. First thing I need to give you help on. How do I go from radians to degrees, degrees back to radians? I have 7 pi over 6 radians. 7 pi over 6 radians. Well, why is the pi in there, right? Why is the pi in there? Here's why the pi is in here. Because I don't want to write this. 7 pi over... I don't want to write that number, radians. I don't think you do either. So I cleaned it up and put it in terms of pi. All right? So 7 pi over 6 radians is the same as what in degrees? Here's how we convert. First thing you have to recognize, is this radians or degrees? 7 pi over 6. What unit measurement is that in? Radians or degrees? Okay, radians. So now everyone go to your formula sheet and look where it says radians. You're given radians, so you look on the formula sheet where it says radians. And I have the same conversion up here on the screen. It's saying take your radians and multiply it by, what's 1 radian equal to? Well, we're not using that. I do not want, that was just visualizing it. I do not want you to use 57.3. The official version, which is on your formula sheet, which is 180 over pi. That's what you multiply your radians by, 180 over pi. Oh, convenient. What's on top and what's on the bottom that's going to cancel each other out? The pi's are gone. And now in my calculator, we do not cross multiply. Does anybody see an equal sign between these? Me neither. So you're not cross multiplying. It's just numerator times numerator. Numerator times numerator divided by the denominator. There is no cross multiplication done when you're converting. So 7 times 180 divided by 6. What's that in degrees now? Let's hear from 12 to start the day out. What's that in degrees? Good job. Not getting off the hook. Let's go. Okay. So 210 degrees is the same as 7 pi over 6. We're going to start graphing these in a minute, but in radians. All right. So that's how you go from radians to degrees. You multiply by 180 over pi. And again, do I always give this to you? Yeah. So you don't have to memorize it. Just find it on the formula sheet. All right. Let's go in reverse now. Let's go in reverse. What if I give you 120 degrees? What is it in radians now? All right. So you're given what? What unit are you given? Degrees. So everyone now go on the formula sheet Everyone see where you start with degrees. It says multiply your degrees by what now? 8. What am I going to multiply this one by?
Pi over 180.
Pi over 180. Now hold on. Whoa. Before we hit up the calcs. Let me do this right now. On my calc. Ready? 120 times, get a little fraction template, right? Pi over 180. That's how many radians are there. But you think I want you to write all that? No? Oh, well, maybe it goes back into a fraction, right? We've done that before. No, it doesn't. I don't want this sloppy thing written down on your papers. So what do I want instead? Clean it up. And when you're leaving the radians, leave the pi there in your answer. All right? Leave it in terms of pi when you're doing radians for me. What's the only thing I need you to do? Simplify. Simplify the 120 over 180 by just plugging it into your calculator and give me the simplified fraction. All right? So instead of writing that sloppy decimal I just had up on the screen, leave the pi in your answer and then just reduce your fraction 120 over 180. And what's that reduced down to? 10?
3, is it 3/4? 2/3.
2/3. So what's my final answer? 2 pi over 3. Or you could have 2/3 pi. Same thing. Leave the pi in your answer when you're giving me radians. Question? Yep, Aaron, go ahead.
When you're giving radians, pi's always going to be on top.
What do you mean given?
Or giving radians.
Like as an answer? Or
yeah.
You can, this is the same as if you want to write this instead.
Okay,
Same
so
thing.
it can't be
As long as the pi is not clearly in the denominator. I
Okay.
can't have, that's a totally different answer.
Okay.
All right. Anything else? All right. I'm not, we won't spend time going back and forth. There's enough on the delta math for you to do. All right. Sometimes, let me go back to my first problem here. Sometimes the pi won't be there and it's still in radians. Okay. Sometimes the pi won't be there. I'll tell you, like convert each of the following radians. There's no symbol for radians. Somebody asked that third period. It was a great question. Like you got a degree symbol. Is there a radian symbol? No. But I will tell you in the problem that it's radians. So this is 5.8 radians. Radians. All right. How do you convert it to degrees? Look on your formula sheet. Look where it says radians. That'll tell you what to multiply by. What do I multiply this 5.8 by? 9? What's it saying on the formula sheet? Take 5.8 radians and multiply it by 180. Perfect. Over pi. Just, hey, there's going to be a 5%. Yeah, Tim, there's going to be like a 5% chance every time the pi's don't cancel, do they? Do the pi's cancel? No, there is no other pi to cancel it, so don't. So what am I just going to do? 5.8 times 180 divided by the denominator pi, and they give me rounding directions, round to the nearest degree. Okay, so sometimes, about 5% of the time, pi's don't cancel. And rounded to the nearest degree, 5.8 radians is about what? 1? Still 1.
Yeah.
So 5.8 times 180 all over pi.
I got 332.31.
Okay, so that 3 keeps it 332 degrees. Yep. Can a radian be well, I should have done this at the beginning. I'm sorry. You guys are probably wondering what the deal with that is. So we've had what? Sigma. We had on what? Friday, beta. Here's the new one. Anybody ever seen those on the frat houses? That's probably the most common one we've talked about. Anybody know that one, that Greek symbol? Theta. Theta. And again, all that means is the angle equals. All right, it's just a way to represent an angle. So can we have negative radians? Well, let me ask you this. Did we do negative degrees? Did we deal with negative degrees? We didn't, Tim?
Oh.
Yeah, we did. You just had one on your quiz, didn't you? Negative degree. So we can have negative radians. Who cares? So negative 2.5, multiply it by what? What's our conversion to go from radians to degrees? 6.
180 over pi.
180 over pi. Again, pi's don't cancel, so you're on your own. Round to the nearest degree. So they're 5% of the, I'd say 5% of the time, so the pi's won't cancel. The other 95, they should. Nine when you're ready. What's the rounded version here?
Negative 143.
Yep, don't drop that negative either. Negative 143 degrees. Okay, feel good here? Radians to degrees, degrees to radians. It's all on your formula sheet. Okay, everything we did with degrees, I want to now do with radians. Starting with, oh boy, coterminal. Coterminal. Let me just review real quick what coterminal means. If I have an angle of 260 and I ask for another angle that's coterminal with it, what did you guys remember doing? Think you don't know? Go ahead.
It's coterminal when it falls on the line.
Well, give me another. No, that's quadrental.
Quadrental.
Give me another angle that looks like 260. What are you doing, Dylan?
620.
Well, I don't. How are you doing it?
Oh, add 360.
I remember adding or subtracting 360. That's what coterminal is. Add or subtract 360. What's my angle in over here? 5 pi over 2. That's in what form, though? That's in radians. So, hey, it's not going to make any sense to do this. That doesn't make sense, right? Because I'm adding a radian in degrees. But so what I need your help with is, what's this in a radian? 360. So I can add and subtract it, right? Because that's what we would do if it was degrees, add and subtract 360. But it's in radians. So I need to figure out what's the 360 version in radians. You guys help me do that. We know how to convert, right? Let's go off to the side here. 360 times what? If you want to put it into radians. This is 360 degrees. What do I need to multiply it by according to your formula sheet? I need to multiply it by what? 1. It's in degrees. What do I need to multiply it by to get to radians? Pi over
20.
Yep. Good job. What's going on? Keep the pi in your answer, right? Keep the pi in your answer. I don't want that sloppy decimal on your calculator. Keep the pi in your answer. Do 360 over 180 for me. $10, 360 over 180?
2.
Just 2. So when you want to add and subtract 360, you're actually adding and subtracting 2 pi in radians. All right? You ready? You can handle this. I wouldn't be showing this. I'd be doing the easy way out if I didn't think you could handle this. So give me another positive angle that's the same as 5 pi over 2. I'm not going to add 360. I'm going to add its equivalent, which is what we just found was what? Add 2 pi to it. Do not even think about giving me 7 pi over 2. Get out of here. Do they have like denominators? Okay, so get a common denominator. We're adding. Get a common denominator. What is it? It's not too bad. What's my common denominator? 2. Do you need to multiply the 5 pi by anything? Nope. We do have to multiply the 2 pi by something because it's over 1. What do you have to multiply 2 pi by? 2, which is going to give you what? Plus 4 pi. So what's a positive version of 5 pi over 2? Combine your numerators. 8. What's a positive version now?
9 pi.
over.
2.
Yep. So 9 pi over 2, 5 pi over 2. Same exact angle. But what did the direction say? Give me a positive and a negative. All right. So how do you think I find the negative then? Take 5 pi over 2 and minus 2 pi. Come on, let's keep going. Still a common denominator of 2, right? Does everyone know we're going to get the same thing on top, but with the subtraction sign? Right? I'm still going to get 5 pi. Still going to have to multiply by 2 and get 4 pi. But what do I get out here now? What? What's your deal?
2 pi with like every
Coterminal?
It's like coterminal.
Well, if it was in degree, no. If it was in degrees, Jared, if I had degrees first, I'd have to add and subtract 360. But because it's in radians, I got to do the 360 equivalent, which is 2 pi.
Okay.
As long as it's in radians, yes, I add and subtract 2 pi. But if it's in degrees, I got to add and subtract what? If it's in degrees. If an angle's in degrees. No. If it's an angle in degrees. Like if I said 200 degrees, give me an angle that's coterminal. You wouldn't add and subtract 2 pi, you'd add and subtract, yes. So you got to know what you're in. See how important it is?
Yeah.
Yes, Aaron.
What if instead of going by radians from the beginning, you just
I'll do that. I'll talk about that in a second. There is another way of doing it, yes. But I think you guys can handle this way, but let me talk about that in a second. What's this still going to give me here?
1 pi?
1 pi over 2. Did I follow the directions?
No.
This is still positive. I needed a positive and a negative. So just like you did with degrees, what do you think I keep doing here until I get a negative? What do you think I have to do to pi over 2 now? Keep subtracting 2 pi. Let's see. Will this give me a negative answer? It should, right? So common denominator of 2. Pi stays pi. What's that 2 pi going to change into? What do I need to multiply it by? 2. So I should get minus 4 pi. Yeah, this will give me a negative answer, right? So what's the negative version of 5 pi over 2? What do you got here? 5. What am I going to get on top? Do I have it? Nope, not today. How about 4? Yep. There you go. So here was the positive version. Here was the negative version. Okay, here's what Aaron was about to spit out before I stopped him. There is another way to do this, which is turn your radians into what? What can you turn a radian into? Degrees, and then add and subtract 360, and then turn it back into radians. I just think that's a pretty long process, Aaron, but if you had to do it, you could. I just think turning it into degrees, adding, subtracting 360, then returning it back into radians.
Oh, would you have to return it back into
Darn right.
radians?
If your answer starts in radians, it better end in radians.
Okay.
All right, and that's a good point. Question in radians, answer in radians every time. All right? All good on coterminal, because we're going to do one more thing we've been doing with degrees, which is graphing it. Sorry if I did that right now. All right, sketch negative 5 pi over 6. That's in radians. I'm not going to teach you how to do it. Here's what I'm going to suggest. You only know how to graph if the angle's in what? So turn it into degrees then. All right? Why am I going to show you something brand new when you could just do it a way we know already? All right? So turn that into degrees by multiplying it by what first? 2. What do I multiply that into to get into degrees?
180 over 5.
Good job. And this is the 95% of the time. The pi's do cancel. Numerator times numerator over the denominator. Do not cross them up. Just numerator times numerator over their denominator. That's going to be negative something. Let me know when you're ready. 9. Whenever you're ready. We got a 9. Are you 9?
Wait.
All right, you're 9, Tim? Well, 5's not here, so, and there's only one, Clayton's the only one absent, so I guess it's you. What do you got, negative?
Negative 150.
150, good. And if you took that quiz earlier, I hope you know how to graph negative 150. Initial side on the x-axis, negative, negative, negative. What quadrant am I going to be in? Make sure you go the right direction. What quad am I in? Negative 150. 9 again. Tim, what quad?
Quad 3.
Yep. Closer to 90 or 180?
Closer to negative 180.
Good job. There it is. Arrow. Starting on the initial side, where should I go here? Negative.
Counterclockwise?
Counter?
No, clock.
Clockwise, right? Think of the clock, clockwise. So we're okay graphing it. Now what's it say? Find the, find the reference angle. Well, how about we just find the reference angle in degrees first? Everyone remember reference angle? Just took the quiz on it. Terminal side and x-axis right there. Can you find what that's going to be in degrees first? Hold your horses on the radians. Can you find what that angle is in degrees right there? That reference angle is what in degrees? 6. Think you got it?
Negative 30.
Whoa, whoa, watch your mouth.
30.
30. Thank you. Ryan remembers, hey, reference angles can't be negative, only positive. So that's 30, but what did it say? Final answer in radians, so convert it back. What are you going to multiply the 30 by to convert it back into radians? What's it say? 14. What's it say on your formula sheet?
Pi over 180.
There you go. We've learned today that anytime I'm going to do this, I'm going to leave the pi in my answer, not a sloppy decimal. And reduce 30 over 180. When you have 30 over 180 reduced, let me know. 13.
0.5 reduced.
How are you reducing it? 30 over 180. Just put it in a fraction template in your calc.
Oh, wait.
One job. You might be a celebrity in the school, but not in this class. All right. We'll get your autograph later.
1 over 6.
Thank you. Great job. If you want to leave the 1 there, you can. Pi over 6, same thing, right? Okay, go ahead. 13 pi over 8. Turn it in degrees so you can graph it. Find its reference angle and then turn it back into radians. You got this. And yeah, it's going to be a decimal. Leave it like that, please. Don't round it. It should be something and a half. You can deal with it. So turn it in degrees, cancel the pi's. So we're all on the same step here in the right direction. How many degrees are in that? 7 when you're ready. How many degrees are in that? No 7 either. Only one person absent. We don't have a 7 or a 5. Go figure, huh? 2.
292.
Got it. Yeah. Be confident, Lex. Be confident. 292.5 degrees. What quadrant am I going to graph that in then? 10. What quad?
The third. The fourth.
Fourth, closer to 270 or 360?
270.
Yep, make it closer to the 270 then. And then a clockwise, counterclockwise arrow. There we go. Reference angle. Right here, right? That's that reference angle right there.
67.5.
How do we get it? How do you get in the reference angle here?
360 minus 292.
Good. 360 minus the 292 and a half. 67 and a half,
Yes.
right? Degrees, but answer said final answer in radians. So I got to multiply that by pi over 180. Leave the pi in your answer and reduce for me. And let me know when you have it. 5, let me know whenever you're ready what the fraction ends up being. Okay, I'm going to sit here and wait, aren't I? 1, there we go, man. 67 and a half over 180. What's that reduced down to?
0.375.
Hit your math button, which is fine. I'd accept that with the pi. I'd like it in fraction though. Hit your math button, turn it back to a fraction. What's it turning into? Yep, 3 pi over 8, everybody. 3 pi over 8. Okay, everyone sees the assignment. Open up the Chromebooks. Let's roll. Good work today. So, hey, this is what the quiz is on tomorrow, what you have right here. Okay? We better just be putting our name on that, Tim.